everybody, welcome to the first day of our intensive SAT Bootcamp. I'll be giving a set of questions and asking you to pause and attempt the problem on your own. Here's your first question, and please get a paper and pencil out and try to attempt this question. The first thing I would consider when looking at this problem is that they already gave you a known function. And this is important because the only thing that they're basically asking us is that to find the x-intercepts. And since we have a known function, this means we can easily put it in a graphing calculator and find the answer. So I would put h of x exactly how you see it. So it's 2x. And here on Desmos, they highlight the two x-intercepts at 0, 0 and 8, 0. And since they already gave us that one of the x-intercepts 0, 0, that means t has to be 8, which means the answer should be D. And I would not recommend solving this algebraically because that will waste a lot of time on the test. Here's the next question. Please pause and attempt the problem on your own. Okay, so the way that I would go about doing this question is just look for the main points of it, because this paragraph is really long and it can distract you from finding the right answer. So they gave us a known function again, f of x, and they just asked us, what does the y-intercept mean? So the y-intercept is at any point when x is 0 and y is some value. Well, when x is 0, that represents just the year 1997. The reason being is because when x increases, it represents an increase in years since 1997. So if x was 1, that indicates that it's 1998. If x is 2, it indicates that it means 1999 or 1998. So in this case, if x is 0, there's no increase or decrease. So that means whatever y-intercept value that we get, it gives you the estimated number of advertisements at 1997. So if we calculate what is f of 0, you just get 9,000. Since anything raised to the power of 0 is just 1. So there's only one thing here that actually, one of the answer choices that goes through all the points that we just made. These two are both wrong because they gave us the wrong y-intercept value, 1708, 1708. We already calculated it as 9,000, which means the answer that we're looking at is just from B and D. Well, they're saying that in B, they're saying that it's during the 5 years, the total or the minimum estimated number was 9,000. But actually, we figured out that this 9,000 value indicates the number of advertisements at 1997. So it should be D. Here's the next question. Although this question seems tricky, it's actually not bad if you know what a quadratic function means, or like the standard form of a quadratic function. So this a value of a quadratic function indicates whether the parabola is going to face upwards or downwards. What I mean by that is when a is positive, your parabola will face upwards, and when a is negative, your parabola will face downwards. In this case, our parabola is clearly facing downwards, so that means a would have to be negative. So that has to be true. Another thing that we can get is that this c value is the same thing as our y-intercept. And so if our y-intercept was positive, our c value would also be positive. If our y-intercept was negative, our c value would also be negative. And if our c value was 0, our y-intercept would be 0. That's how it works. And although we don't know what the actual y-intercept value is, we can see that it's clearly positive. which means that C would have to be a positive number looking at this graph. So number 3 would have to be true. Now to test out whether B is true, you could do either two ways. You could do it algebraically, which could take a lot of time, or you could do it through Desmos, which is way easier. And the way that we're going to figure out whether B is true or not is just looking at another important feature of the graph, which is the vertex positive or negative? You can see here that for the vertex of the parabola, both the x and y is positive. It's on the positive axis, right? So we're going to look to see that if B changes, will the vertex stay positive like we want, or will it become negative? And since we already know that number 1 and number 3 is true, we can input that into Desmos just how it is. So I'll show you what I mean. Now you're going to put the slider for all of them. And we know that A has to be some negative number, so I just put -4. And C has to be some positive value. So let's see what happens when B is negative. Well, we can see that our vertex becomes, or our x-coordinate for the vertex becomes negative, which is something that we don't want. So we already know that B can't be negative. And when B becomes positive, we can see it's exactly what we want our graph to look like, having a positive x-coordinate for the vertex and a positive y-coordinate for the vertex, which means that B should be positive as well. So the full answer should be D. Here is your next question. Now, whenever I see a quadratic function, this h, and it's asking me what is the maximum or minimum, you should automatically think about it's asking me something about the vertex. A vertex of a quadratic function is usually the maximum or minimum point. So in this case, the vertex of the function indicates both the maximum height and the seconds it takes to get the maximum height. So what we're going to do here is we're just going to graph this onto Desmos, and when we graph it, we're going to see that there's going to be the highest point of the parabola. This highest point will tell us when does the ball reach its maximum height, and in how many seconds does the ball reach the maximum height. So just by graphing it onto Desmos, we can figure out the answer for both of these two questions without having to do any math. And I'll show you how to do that. Now that we have our function graphed, we're going to scroll all the way to the top until we see a point that looks like the vertex. And we can see here that we have 8, and that's the seconds, 8 seconds, and 1,024 feet for the maximum height. So we would get A and C, and those would be your correct answers. Here's your next question. Whenever I see a question that has constants, and they give me some points that I know are supposed to be in the graph, I just go ahead and plug it in and see what I can do with it. So in this case, they said that when x is 2, that means this should equal 0. And they also said that when x is 0, this should equal this, right? So we already know that any exponent or anything raised to the power of 0 should always give you 1. So when a is raised to the power of 0, this is 1, no matter what. So we can solve for b just by doing this. And you can see that when we move 1 to the other side, you're going to get b is equal to 324. And that should be your final answer. this is your next question. Please pause and attempt the problem on your own. Okay, so the first thing I would consider is, what does it mean when an equation has infinitely many solutions? Well, to have infinitely many solutions, your two equations have to be identical. There should be nothing that differentiates between the two of them. When it has a solution, that means something in the problem, something in the two equations are different from one another. But we want infinitely many solutions, and that's a very important point. So what I would do is I would just expand this and see what we know from there. So we already know that jx and 3/4 x have to be the same. And since this x is already common, that means our j should be also 3/4. So j would have to be 3/4 for this to be the same, right? So now we have this. And I'm going to sub in this 3/4 right here as well. Now we need to solve for k and think about what value of k will get me positive 15, that these equations can be exactly identical. So we can just set up a mini equation here. And from there, we can see that k would have to be negative 20. Here's our next question. Again, like the previous question that we did, whenever I have something that has a lot of unknown constants and they give me points, I like to just plug it in and just see what we know from there. So in this case, they said when x is equal to c, our whole function should equal 8. And when x is equal to 2c, our whole function should equal 350. Right? Well, one thing that I think that we should do is try to find the value of b, or try to rewrite a into b. So let's look here. AC is equal to 8 plus b. Well, what is A to C and what does AC have in common? Well, if we think about it, AC, sorry about that, AC is basically, if we just square it, we would get A to C. So that's how we can think about it. So if we want to get what A to C is in terms of B, we can say that A to C, or if it makes it easier, is 8 plus b squared, because we essentially squared whatever we got here and here to get what a to the power of 2c is. Since these two are basically equivalent, we can plug that in and we can get 8 plus b squared minus b equals 350. Now you could solve this by hand, but there's actually an easier way if we just plug this equation into Desmos, and it will give us the two solutions of b. And I substituted x for b, or I substituted b for x because that's how Desmos, but Desmos doesn't like anything besides x and y. But whatever we got negative 26 and 11. Those are our two possible values for b, and that's what I would input.